Hello, today we're going to be doing 5.1, the Fundamental Theorem and Factor Theorem. So this idea is something we've been leading you towards in the past previous units. The Fundamental Theorem of Algebra states that if a function f of x is a polynomial with a degree of n, then the polynomial has n number of roots. Basically what this means is the degree of the polynomial, whether it's a cubic, quartic, quadratic, that always will match with the number of roots or the number of solutions. So in this first example, notice that we have x squared. So since that's the highest degree, that tells us we're going to have 2 roots. Here we look at this next one. This one's a little bit bigger of a polynomial. It's x to the 5th, therefore it would have 5 roots. So the roots or the solutions always match the degree. So here's our first example where we're actually going to solve for those specific roots. Notice it's 3x cubed. So then we're expecting 3 solutions here since it's x to the 3rd. Now what we're going to do is use that synthetic division process that we used in the last unit. Notice that they tell us that the root is x equals -4. We're trying to find the other 2 roots using that. So start with the -4, put it in our little half box, and then do the process you guys have practiced quite a bit. So line up your coefficients, and then we'll do synthetic substitution. -4 times 3 is -12. Add what's up above, we get 1. Multiply. Add here, this gives us -2. Now notice at the end what we get. -4 times -2, that ends up being +8. So -8 plus 8 means that we have a remainder of 0. I just put the colon down here as a reminder that the last number is the remainder. This is good. We always are expecting to get a remainder of 0 if it's a true root. If it divides in there nicely, it should never have a remainder, okay? Other than 0. So then what we end up with is 3x squared plus x minus 2. And we're going to set that equal to 0 because we want to actually solve this. We're trying to find the other 2 roots, okay? So I'm going to use the old box method where we do the a times c over b, since we have a value of 3 for a. So then this is -6, this is 1. Factors of -6 that add to make 1 are 3 and -2. Then we'll make our box. So 3x squared, -2 goes at the end, and then the 3 and the -2 are the side boxes. Doesn't matter the order. So here we would get 3x, down here we would get -2, here we would get x, and here we would get 1. So then this factors into x plus 1 and 3x minus 2. So from there, we can go ahead and solve. We know that the solution to x plus 1 is just going to be the opposite. It's going to be -1. So there's our second root. And then this one you might want to set equal to 0 and just solve so you don't make any mistakes along the way. We would end up with 3x equals 2, divide by 3, and we get x equals 2/3. All right, now that's 2 of our solutions. Don't forget that x equals -4 was one of the other roots, because sometimes you're not going to be given the root, and you have to list that out as an answer as well. Here's our next one. Solve the polynomial function. This time, again, they gave us x equals 5. It's x to the 3rd, so we're expecting 3 answers in the end, where this is one of them. So when you line this one up, 5 is going to go in our half box. Remember, we're starting with 1 here, but since we're missing the x squared term, we're going to fill in a 0. So 1, 0, -19, -30. Okay, I'm going to go a little bit quicker through these since you guys have seen this so much. Multiply, add, we get 5. Multiply, we get 25. Add, we get -6. Multiply here. What did I do wrong? That's not -6, okay? Now the reason I knew that I was doing something wrong there is because I know that I need to end with +30, because these 2 numbers have to reduce down to 0. Okay? If you don't get 0 at the end, something went wrong. So since we started with x cubed, that means this is x squared plus 5x plus 6 equals 0, and this is going to factor really nicely. It's going to be x. Factors of 6 that add to make 5 are +2 and x plus 3. So then the solutions are -2 and -3. Again, there's 2 of our 3 solutions. The first one was the one that we had up here. Okay, now I've kind of alluded to this idea already, but the factor theorem states that if my remainder is 0, then x minus k is a factor of the polynomial. So we can prove here, if we get 0, that x minus 4 would be a factor of our larger polynomial if the last number is 0. So remember, when it's given to you like this form, you're trying to think of what's the solution to x minus 4, and that would be positive 4. So here we're going to use positive 4 instead. Line these numbers up. Drop down the 2, multiply, add, multiply, add to give us 3. 4 times 3 is 12, and just like we were expecting, negative 12 plus 12 is 0. So here, we're not trying to solve for the whole polynomial, we're just trying to divide and show that it's a true factor. So our final answer in this one would be 2x squared plus x plus 3. We're trying to divide this and get the polynomial out of it. We could go ahead and solve this. We could set it equal to 0. We would just get some rather not nice solutions. This would take the quadratic formula. Okay, now here's the moment of truth. What if we don't have a solution given to us? How are we going to figure out what zeros there are? I mean, we're expecting 3 solutions. We don't really want to just like guess and check. There is a method for that, but we're going to do something more efficient. We are going to split screen or jump to Desmos here. As soon as I find it. There it is. We are going to use Desmos to graph this and see where it intercepts on the x-axis, because those are the same thing as roots, x-intercepts. So the way you're going to type this in, here's x right there, and then if you want to get an exponent bigger than 2, you're going to have to hit this a to the b power button, and then that's going to give us 3, arrow over, and then just type in the rest. So plus x squared minus x plus 15. If you need to take a second to pause, and then you can look at that. So now what I'm going to do, I just want to zoom in to the points where we cross the x-axis. Notice we cross perfectly at -3, which is great, but we only cross 1 time, which is kind of interesting because we're expecting 3 solutions. And you've probably already guessed why we're only crossing 1 time, but I'll get to that in just a second. So we're going to assume that x equals -3 is one of our answers. If it is a true factor, or a true solution, I should say, then it will work out where we have a remainder of 0 when we use the synthetic substitution method. So we're going to have 1, 1, -1, and 15. So let's go ahead and break this down. We would multiply, we'd get -3, add to give us -2, multiply to give us 6, add to give 5, and -3 times 5 is -15. Okay, if we didn't get 0 at the end, something went wrong. So that means x equals -3 was a solution, so that's 1 of 3. Now the reason we didn't see any other x-intercepts on the graph in a nice point is because these are going to be imaginary. There's not factors of 5 that add to make -2. So in this case, we probably just want to use the quadratic formula. So I'll write that out here for you. You guys have seen this plenty at this point. All right, so this is our A, B, and C. So we would get x equals +2 plus or minus, this would be -2 squared minus 4 times 1 times 5, all over 2 times 1. Then what we're going to see is it's 2 plus or minus, and however you get this, if you want to type it in your calculator or do it out by hand, it ends up being -16 over 2. So then x equals 2 plus or minus, the square root of 16 normally is 4, but since it's negative, we got to throw in that I. That's the reason that we didn't touch any of the x-intercepts, is because we have imaginary solutions. And imaginary solutions don't cross the x-axis like normal roots or real roots. So then the simplified version of this is not 2. 2 divided by 2 is 1, so it's 1 plus or minus 2i if you want to reduce that. And there's our 2 solutions along with the x equals -3. Here's our next one. Find all the zeros of f of x equal to x to the fourth minus x squared minus 12. So this time we're going up a little bit. It's x to the fourth. So we're expecting 4 solutions. Let's go ahead and split screen with Desmos here one more time. And now we're going to delete that old equation and we're going to type in this new one. So x to the fourth minus x squared minus 12. And then I'm just going to slide this off. So this time, looks like we only cross at 2 points, which is fine. We cross at -2 and +2. And we're going to need to use both of those roots to get our final answers. So in this case, where you're given 2 real roots and you have to break it down, we're going to use both of those roots in the synthetic division process. So the first number is 1. Notice we're missing an x to the third, so that would be 0, and we're missing a 0x. So it actually goes 1, 0, -1, 0, -12. Now I used 2 for the first number. It doesn't matter if you use 2 or -2. You can go in either order. It'll still result in the same final answer. I drop down the 1, multiply, add, multiply, add, and we are definitely expecting 0 at the end here if we're doing this right. 2 times 6 is 12, so we do end up with 0. Now, we broke it down. We went from x to the fourth. This would be x to the third, but in our case, we need to keep going. We want to try to get it down to at least a quadratic. Okay, so then now I'm going to take this x equals -2. I'm going to just repeat the process with the same numbers I have filled out, except for the very end. Don't include the 0. Just go to the 6. So we're going to drop down the 1, multiply, add here, we would get 0, multiply, add, we get 3, multiply, we get -6. So this is what I was meaning, like you have to leave off the 0 because we want to get to 0 a second time down here. So 6 minus 6 is 0. And so now our new polynomial. Notice we started with x to the fourth. This line here would have been x to the third. So since we've dropped it down one more stage, this is actually x squared. And it would be x squared plus 3 equals 0. And we can solve for this one really easily. We would subtract 3 from both sides. We would get x squared equals -3. Take the square root. And remember, when you take the square root, you're getting a plus or minus. So we need to get our 2 solutions along with the original 2. And this would be I square root of 3. It was imaginary, which again, we expected that. So we kind of know we did it right there. All right, and don't forget about these 2. That's it for this one.